Algebra 2, Lesson 93, the discriminant. So, I'm just going to teach this one my way. I don't need the book for this one. The discriminant is part of the quadratic formula. So we know the quadratic formula here is negative b plus or minus square root of b squared minus 4ac all over 2a. Now the discriminant in the quadratic formula is this piece right here. The b squared minus 4ac. Now, the reason why this is the discriminant is because this is the all-important part of the equation that tells us whether or not our answer to our quadratic is going to be a real number, a complex number, or an irrational number, or an imaginary number. So remember, real numbers are whole numbers, irrational numbers, or what are we calling it? Or real numbers are all in the, where's my brain today? I should have took a chill pill before I made this video. Or maybe had some coffee. All right, I've gathered my thoughts. We're ready to learn again. So, if we remember our breakup of numbers, we have real numbers, right? And the split of real, we have rational and irrational, and then in rational we have wholes, counting, and integers. So the main distinction, and then outside of reals, over here we have unreal numbers, which is where our number I lives, our complex number, right? So we'll call this complex. So this discriminant is going to tell us whether or not our answer is going to be complex, real, or a whole number. Now, the way we know that is if b squared minus 4ac equals 0, then we have a whole number. Now, if b squared minus 4ac equals a positive number, then we're going to have two real number solutions. So this is going to be two real numbers. So the difference here is if it's equal to 0, then we have one whole number. I'll put the number 1 there. So one whole number. If it's a positive number, we have two real numbers. Now, if b squared minus 4ac equals a negative number, then we're going to have complex conjugates numbers. Well, that was too small. We're going to have two complex numbers, which happen to be conjugates. Conjugates. And hopefully we'll have time in class, and hopefully I explained to you guys the different types of these. But this is the answer that we're looking for. So when we're given a problem, they tell us use the discriminant to determine what kind of answer we're going to get. Our answer is either going to be one whole number, two real numbers, or two complex conjugates. All right. So let's use some examples and figure out which one our quadratics will lie in. So let's say we have the quadratic formula of x squared equals negative 3x plus 2. Well, first thing I'm going to do is I'm going to set this equal to 0. So that's going to be x squared plus 3x minus 2 equals 0. And then I'm just going to solve the discriminant portion, which, again, we said was b squared minus 4ac. So I'll take b squared, which is 3 squared minus 4 times 1 times negative 2. Let's see here. This is going to be 9 minus 4, negative 8. 9 minus negative 8. That becomes plus positive. So then I have 17. So then I go back up here. I got a positive number. So my answer is going to be two real numbers. So for my answer block, I'm going to write two real numbers. And that's my answer to that problem, right? So that's all they're asking for, is that you tell us whether or not it has two real numbers, whether or not it's two complex conjugates, or one whole number. I'll go ahead and do one more example so we can make sure we've got the gist of this. So let's say our other quadratic is negative 4x equals negative 3x squared minus 3. I'm going to set this equal to 0, so then I'll get 3x squared minus 4x plus 3 equals 0. And then I'll plug in b squared minus 4ac. So I've got negative 4 squared minus 4 times 3 times 3. So negative 4 squared is positive 16. Let's see here. 4 times 3 is 12. 12 times 3 is 36. So 16 minus 36 is going to give me negative 20. So since my answer is a negative number, my answer is going to be 2 complex conjugates. That is my answer. Is that all we're doing here? Yep. A couple of short lessons today. All right. If you guys have any questions, let me know on Moodle, and I will see you in class.